for a second my video wasn't working, so I'm just going to repeat this. So we have the a rectangular container with a square base and also a lid that has to have 2,500 cubic feet, and we are given the cost of the material to build this container. The bottom has to be costs $2 per square foot, the top $3, and everything else $1 per square foot. They want us to minimize cost. Find X and H for a minimum cost. Good. So first of all, I have to create the cost function. So the cost, in this case, of age, X and age is the base, the area of the base is x squared. X squared times 2. So it's 2x squared plus. The cost for the top is the area times the cost. So it's x squared times 3. So it's 3x squared plus. The four sides are all the same size. All of them. X times h. So it's 4 times x times h, which is the area, times 1. I shouldn't even write it because that's the cost per square foot. Good. So this, I wrote it as a function of two variables. It is. However, we have this condition. The condition is that the volume is 2,500 cubic feet. Well, what is the formula for the volume? Area of the base times the height. So it's x squared times h. This is sufficient for us to find h and plug it in. So then h equals 2,500 divided by x squared. I have to replace h in the formula for the cost, and now finally the cost is a function of a single variable. 2x squared plus 3x squared is 5x squared plus 4x multiplied by this, 2,500 over x squared. Of course, I will simplify an x. So then the cost function equals 5x squared plus 102 zeros over x. So I found the function that I have to minimize. Let's see if we have any questions on the way on the method or steps that we performed to find the cost function. See if you have any questions before we continue. Is this okay? Is this okay?
Yes, it's okay.
Good. So now we have to differentiate. So we will differentiate the cost function. So c prime of x equals 10x minus 10,000 divided by x squared. Find the least common denominator, which is x squared. 10x cubed minus 10,000. Now, of course, c prime of x is 0 or c prime of x is undefined. As you remember, these are possibilities for critical numbers. Well, there is no discussion here because x will never be 0. If x is 0, there is no box or container. C prime is 0, a fraction is 0 only if the numerator is 0. So 10x cubed equals 10,000. Of course, I will simplify by 10, and I will apply the cube root, of course, so I get that x equals 10. Very nice. And this was in feet. So if x is 10, 2,500 over 100, it means that the height is 25 feet. This is good, but it's not enough. Not enough. How come? I have to show that x equals 10 gives a minimum. So I have to create a table. I have to find C prime. I have the critical number, which is 10. I have to study the sign left and right. So, of course, it's not going to be 0. But if I have 0, it's negative. And beyond will be positive. I have to find the cost at this number. But I can guarantee that this is the absolute minimum because of the signs of the first derivative. But I have to find it. So I will replace x by 10 and h by 25. Or I simply replace x by 10 in here. So the same thing. So C of 10 is 500 plus 1,000. So this is 1,500. And this is the minimum cost. So the dimensions of the container, they will guarantee the minimum cost of $1,500 is 10 for the side of the square and 25 for the height. Any questions? Any questions? Okay, let's refresh our memory a little bit on chapter 2. And chapter 2 review is on page 255. The last two classes we're going to continue reviewing for the final exam. I send you an email. Nobody's obligated to complete the survey, but number one, if you do, I give an incentive. I know, not another survey. I know, I agree with you. But if you do complete it and you upload the last page with survey completed, I will reward you for that. Don't upload anything else, but just the last page. Okay, so see if we want to differentiate, refresh our memory on how to differentiate log and exponentials. Or we are okay with that.
Could we do 29?
Yes, of course. Let's look at 29. Very good. I'm on page 9. 29. So y equals 3 to the x times, I'm going to change that. I'll give you the formula, but there is no problem with logging any other base. I'm going to copy it as is. I'm not going to test you on that because it's not in the book. I think that they forgot and they put it in. So, but let me explain. So if we have natural log x and we differentiate, this is 1 over x. But if we have any other log, like log base a of x prime, when we differentiate something like this, we basically have to change. You don't have to memorize this. Well, I'm not going to test you on this. But what has to be done is we have to change the base into natural log. And there is a very simple change of base formula. So log base a of x with natural log, we will be natural log of the number over natural log of the previous base. So that's why the formula when we differentiate this is 1 over x natural log a. So when I differentiate log base 4, I will have whatever 1 and also 1 over natural log 4 because I have to change. Maybe that's what they meant. to change log base 4 into log base natural log over natural log of 4, and probably that's what they meant, I guess. So we can do that. So 3 to the x times natural log of 2x plus 1 divided by natural log 4. Okay? And now we can differentiate. So then y prime is, remember this is a product. 1 over natural log 4 can stay outside because it's just a constant. I differentiate 3, oh, we also never differentiated a number to the x. Okay. So I'll come back to it in a second. So we know that e to the x prime is e to the x. But if we have a to the x prime, we have to write a to the x times natural log a. Again, we have not done this because there was nothing in the book, in the regular chapter, regular section, with anything else but the base e. So that's why I never showed you this formula. So in order to differentiate 3 to the x, we have to write 3 to the x times natural log 3. No, I will not test you on this because we haven't discussed this, but since we started this problem, let's finish it. So the first function prime times the second function plus the first function times the second function prime, which is 1 over 2x plus 1 times the inner function prime, which is 2. And you can leave it as is. So the reason why I did not show this is because we didn't find anything except now 2 problems in the review. So we only looked at e to the x. E to the x prime, you can say, why don't you multiply by natural log e? True, but this is 1. It's the same formula. But when I multiply by natural log e, I get 1. So that's why it looks different, because natural log a is not 1. But it's exactly the same formula. Good. Again, you don't have to worry about this, and you don't have to worry about the natural log of a different base. But this part is not difficult. You can always use the change of base formula. But we have not done that. I did not practice this with you, so it's okay. The same thing with 28. But you can change the base into log x over natural log x over natural log 2. That is okay. Okay.
Can we try another one?
Yes, yes, please choose anything you want.
Can we do 19?
You said 19?
Yes.
Yes, of course. Let's look at 19. In 19, we have y equals natural log of x to the 4th plus 5. So the formula for natural log prime, so y prime equals 1 over x to the 4th, 1 over the function times the function prime, and the function prime is 4x to the 3rd. You cannot simplify anything. You can write it condensed if you want. X to the 4th plus 5. Good. Let's look a little bit at limits. And that's page 188. Okay. Let's look at some limits. Find each limit if it exists, and so on and so forth. Any limits?
Can we do 20?
Yes, very good. Let's take a look at 20. Limit as x approaches -7 from other side, x squared plus 2x minus 35 divided by x plus 7. Good. So when calculating a limit, I have to plug it in to see the situation. And when I plug in, the denominator is definitely 0. Let's see the numerator. 49 minus 14 minus 35. 49 minus 49 is 0. This is a good sign. Why is it a good sign? Because there is hope. Okay, so when I plug in -7 and I got 0, I know the numerator, as we discussed, must have a factor of x plus 7. Otherwise, I would have never gotten 0. Now, the other thing is that I have to find the other factor. So x squared plus 2x minus 35 factors into x plus 7, and can anyone give us the other factor? Can anyone give us the other factor, please?
Is it x minus 7?
So x plus 7 times x minus 7 would be x squared minus 49.
Oh,
That's okay. Say it again.
Minus 5.
Yes, very good. Indeed, it's x minus 5. So then we eliminate the problem. We eliminated the 0 over 0 situation. And now when I plug in -7 minus 5, nice, -12. Good. Let's see if we want to work on other limits. I guess not. Okay, let's look at some differentiation.
Can we do 51?
Yes, of course. Let's look at 51. In 51, we have g of x equals 5 minus x squared and 2x minus 1 to the 5th. Good. Okay. So g prime, I realize that there is a product rule here. So the first function prime to 5 minus x to 2 minus 1 times the inner function prime times the second function plus the first function times the second function prime 5 to x minus 1 to the 4th times the inner function prime. I have to rearrange it a little bit. -2, 5 minus x, 2x minus 1 to the 5th, plus 10, 5 minus x squared, 2x minus 1 to the 4th. Now I will factor out the greatest common factor, 2, 5 minus x to the first power, and 2x minus 1 to the 4th power. This is out where there is a negative sign. This is out. From 5, I took out 4, so I have 1 left over, or inside. Factor of the 2, so I have positive 5. From these two, one of them is out, and all these 4 are out. So the simplified form just here in brackets, -2x plus 1 plus 25 minus 5x. Negative 7x plus 26. So therefore, the final answer, 2, 5 minus x, 2x minus 1 to the fourth, negative 7x plus 26. And that is the final form. Any questions? We have a couple of minutes left, so let's choose one more. And then I will wish you a happy Thanksgiving, and we'll see each other next Tuesday.
Can we try 52?
52, of course. And please come to class after you take the test on Tuesday, so we can continue our review. We said 52. 52, f of x equals x to the fifth minus 3, everything to power 7. Good. So f prime of x equals 7, x to the fifth minus 3, 7 minus 1, times the inner function prime, 5x to the fourth. Put this in front, 35, x to the fourth, x to the fifth minus 3 to the sixth power. And that's final. Any questions?